Ladies and gentlemen, welcome to this Norwegian Petroleum Society webinar. My name is Hans Petter Fuglesang. I'm the chairman of FUGLESANGS and of FUGLESANGS Subsea. Today the main topic is pipe repair of large and small pipes with polymer composites reinforced with Kevlar and possibly ceramics. But first, let me tell you a little bit about FUGLESANGS. We are established in 1916 and we have served the Norwegian industry for 104 years. Really active we became in the oil and gas industry already in 1971. I will introduce you a little bit to FUGLESANGS. We do work a lot with pipes. We are the representative office of EBK in Norway, that is Eisenbach-Kramer, a producer of submerged arc welded pipes from 18-inch to 180-inch. We produce line pipe, riser pipe, construction pipe, process pipe, machine pipes in large diameters. And we have some special technologies. One which I will mention to you is the impander technology, that is squeezing the pipe from the outside. This gives you superior dimensional tolerances to only expanding the pipe from the inside mechanically. Well, then we have another area which we are working on, which we are not going to cover much today, but that is pumps. We work and make pumps from 1000 kilowatts to 3000 kilowatts in our location here at Alnabru. We make subsea pumps without mechanical seals, without barrier fluid systems, and this is quite important when you have subsea pumps because you don't need all the umbilicals down with the fluid for lubrication of the seals. We also have a magnetic coupling then to drive the pump. We also have a hydraulic coupling, which means we do not need frequency converters topside. We can vary the speed of the pump with this hydraulic torque converter, which sits between the pump and the motor. Gigantic savings for the oil and gas industry. One small correction. Regarding EBK, I heard myself say they produced pipes from 18-inch to 180-inch. That is not quite correct. It should be from 12-inch to 180-inch diameter. So please note. One more thing with regard to questions and answers. This is a pre-recorded session. We recorded it 2 days ago. So the questions you are coming in, we necessarily have to take at the end of this session. Then we are going to move on to pipe repair. And I ask you please to think of all the savings you can have when you repair pipes in the way we are explaining to you now, because there are very big savings in being able to repair instead of changing large pipe pieces or spool pieces. So what I'm going to do now is to get you into a PowerPoint presentation, and please remember my phone number. I'm almost available 24/7 and you can call me anytime, and if you have any questions, and my phone number is 91542002. And then we move on to the PowerPoint presentation. Okay, now I'll take you through a job we did on Oseberg South platform and Oseberg East platform in respectively 2018 and 2020. That is this summer. The job is just completed. So in the PowerPoint that I'll now show you, we go on to the pipe repair and how we do it. The picture you see here is actually done by hand on a line pipe. What we are doing on the Oseberg platform in both cases, We worked between 2 meters depth and 18 meters depth, and what we did was to repair caissons. These caissons are about 40 meters underwater and 30 meters above water, but like I said, we worked underwater. Problem was that there had been considerable corrosion. They had large cracks of over a meter and a lot of holes, so the structural integrity was not in place, and the holes resulted in leaks, so we got marine growth into strainers, filters, valves, etc. This was not good because it stopped the function of a lot of equipment on the platform. So the option was either to change the complete caisson or to perform a repair. So basically we're using the same method as you see in the slide. You have a lot of other typical challenges, both structural and pipe messy. So what you see here is a very bad problem. We could actually solve it. I don't think it would normally be solved, but we could repair it. But again, if you look at point 5, it is leaks in sea water caissons that we are concerned about today. And here out on the Osberg platforms, we see the platform, and the challenge here was of course that we had to do a lot of subsea work. Here you see a picture, you see the 3 arrows. The 3 arrows points at the 3 caissons we were repairing on both platforms. So we had a lot of key challenges that we got from Equinor. They told us they wanted us to calculate the repair using 2 tons wave load per square meter, and also they wanted us to have internal pressure of 6 bar into the consideration. The holes were quite big, up to 300 millimeters, and like I mentioned before, there were some big cracks. So we went to work to qualify these resins and procedures. So in our workshop in Oslo, we developed kind of a test laboratory, big scale, where we did apply on tubes of the same quality as the caissons, and we shot blasted and applied underwater the different resins, and we did a lot of testing like you see to the right there, where we pull a lot of dollies to check the adhesion of the primer to the substrate, the steel pipe, and also after having done a lot of layers of Kevlar pre-wetted in polymer essence. Then we tested also interlayer adhesion. So when we had decided more or less on the materials, we went to a full scale test at Killingøy. So we did this on 14 meters depth. On the tube to the right there, we have cut it across, and you see the steel pipe, and what you see is 18 layers of Kevlar tape with 50% overlap. The tape is 100 millimeters wide, and every round when we apply it with the machine to the left, we are secured a 50% overlap. So Equinor told us that they wanted this to comply with international standards, and this is what we did. So we used the ISO TS 24.87, but we can also use the ASME PPC-2. So with all the information we now had collected, also approximate size of the holes and the cracks from divers that had been down a year or 2 before, we started the calculation to find out how many layers we needed to do. In this we have rather sophisticated data programs and computer programs and finite element analysis programs that we can apply. So this is the next slide is a typical slide of the planning. We had all the holes drawn in and the one big crack, and we decided preliminary on the different number of layers. Again, we worked between 2 meters and 20 meters depth. So the process is now that we have to remove the mussels and marine growth. You see on the bottom left of the picture, we just put in a picture of what it looked like. This is mussels and, like I said, marine growth. So step one is to get rid of that. We used a good old-fashioned system in this case, which turned out to be fairly efficient. We were using a bark spade to remove it. And after that, we measured exactly the holes of that we found, so we could prepare special lids for each of the holes. And then we had to recalculate while on the platform. We brought the data equipment with us, and we also transmitted it to our supplier 3X Engineering in Monaco to have calculations so we got the right amount of layers, etc. for the application. So here again, you see that. Then we planned on the areas to be shot blasted or sandblasted rather, and primed. The priming was applied by hand with divers. You see a lot of strings here. These strings are magnets to help to hold the divers in position. So he's actually having a bucket lowered from topside so that he can put on the primer. Topside, we do mix the resin and prepare also the tapes. So you see a ready spool on the right side, and this spool will then be brought down by a guideline to the divers who will put it onto the machine. And the machine is, here you can see a video. It goes around and around with the tape. This facilitates the job tremendously. We also have some tees that had to be wrapped manually. On the left, you saw something done the day before. The diver operating the machine. Here are a couple of the guys during the session at Killingøy when we pre-qualified. DNV has participated in the project from the beginning to end for the qualification, and the very good results we got was, if you look down to the right, you see that we get an average of 11.2 megapascal applying the primer by hand. The requirement from Equinor was to have the NORSOC quality standard for coating of 5 megapascal that is used for above water. So we were quite proud to get an adhesion of 11.2 average for below water application. Interesting part here too is that we had cohesive failures. When you test coatings, you have to look at two types of failures, either cohesive or adhesive. When you look at adhesive, then you lose adhesion between the substrate and the coating. When you look at cohesive, it's actually the coating itself that breaks. This, of course, is very much advantageous because then you know that the adhesion to the substrate is larger than the test result that you get. So then there's one more thing to mention, and that is that we are in the splash zone. quite difficult if there are big waves, and in the North Sea it can be big waves. So to apply all the work that I've explained to you above with divers, there will obviously be some waiting time. So we have, together with Ocean Tech in Trondheim, now come quite far in developing a fully robotized process. This means that we will fully automatically, with robots, remove the marine growth, and we will do the shot blasting, and we have now come quite far in doing the priming, and we need some more development work in getting the spools into the machine, etc. But this makes the work much faster and much less expensive. So I thought of showing to you, this is basically it, and I encourage you to ask questions. I've added a small little video on the end here, and that is we're doing basically almost the same thing for tank repair. Now we are above water, but I want you to see this little movie.
Tanks are damaged and must be repaired. The question is how to complete this operation quickly and efficiently. The typical damage, either mechanical or corrosive, presenting a leakage or not, is often fixed using welding. However, this technique involves draining the tank and taking many preventive measures because the heat associated with this process represents a high-risk activity. To solve this problem, 3X has developed Tank Kit and Reinforced Kit Patch. These products are cold welding systems allowing to repair damages without altering the operation. The first one is designed for emergencies, and the other one is a long-term solution with a repair lifetime up to 20 years. So, how do they work? Tank Kit is a pre-engineered composite solution ready to be used. To apply it, just clean and prepare the surface. Install the steel plate using magnets over the defected area and recover with Kevlar patches impregnated with specific resin. This temporary solution is suitable for tanks up to 20 meters and defects up to 100 millimeters. The second product, Reinforced Kit Patch, uses the same technology, composite materials based on patch application. The difference is that Reinforced Kit Patch is tailor-made for each repair. 3X team first designs a specific solution according to the damage and then performs the repair. This customized solution has no limits in terms of tank or defect size, and the repair complies with the international standards ISO 24.817 and ASME PCC 2. Thanks to these products, damaged tanks are now easy to repair. When the situation is critical, use Tank Kit. If you need a long-term solution, use Reinforced Kit Patch.
This is actually a job we did a few weeks ago, also out on the Oseberg field, and we have last week had people out at the Kvitebjørn platform also doing this type of repair. So this could, I think, be quite interesting, as we can repair tanks with internal pressure of 10 bar, and we also can work up to above 100 degrees C. So basically this is it for today, and like I said, if I can be of any help with questions, our staff with lots of engineers will be to your service. So I hope you found it interesting and that we can help you repair in the future. Thank you very much.